Hello again. Miss Terry Dabbit here. We got a new video on domain of rational numbers. Domain of rational numbers. And remember, my only goal is to do my best to just make math easy. So let's begin. What are rational functions? Rational functions are functions that contain fractions involving polynomials. So basically they result from two polynomials that are divided. When they're divided, your numerator is going to be known as p of x. Your denominator is going to be known as q of x. Both of them are going to be polynomials. And there's an extra restriction. You're going to see a place where q of x cannot be equal to 0. Okay, why? It's going to make the rational function undefined, first of all. Where does this come from? It comes from your fraction rules. If you think about your fraction rules, you never can have 0 in the bottom. It's going to make the fraction undefined. So we add this restriction on our rational function to show where it's going to make that bottom 0. What that is called is referred to as the domain. So the domain of a rational function is going to be all of the values of x, every single thing that I can put into that rational number, a rational function, except for where q of x, or my denominator, is going to be 0. So we write it out by saying, well, okay, my domain can be all of these things except x cannot be equal to something. So anything that you're going to substitute in for x that's going to make that denominator 0 has to be a part of that domain. So here's an example. Here's a domain. All real numbers except x cannot equal blank. And remember that blank is whatever is going to make that denominator 0. Okay, here's an example. All real numbers except x cannot be equal to 8. So I found that 8. I put my number in there because I figured out if I plug 8 into this rational function, it's going to make my denominator 0. So I cannot use the number 8. Okay, how did I find that? How did I find that number 8? Not too hard. You first of all, you don't worry about what's in the denominator, but you set the denominator equal to 0. The numerator, don't worry about it. Set the denominator equal to 0 and then solve it out. Whatever answer you get, those are going to be your undefined values that you're going to put within your domain. What does this mean in the real world? So you're learning domain and you're like, okay, what does this mean? It doesn't make sense to me. How does this work in the real world? You have to remember that domain eliminates all the values that are going to make that denominator 0. In a real world application, this means the situation just doesn't make any sense. Like there's no way possible that could even happen. Like it just doesn't make sense. So yes, you would have to have a domain. Here's an example. Suppose that you're taking some students on a field trip. You know a couple things. You know how many seats are on the bus. You probably know the cost, how to rent one bus, 2 bus, 3 bus. You probably even know your budget. But what you need to find out is your task is to find out how much that each student is going to have to pay. You would perform a mathematical model. The mathematical model would involve a bunch of equations. You would come up with this x being what each student is going to pay. But guess what? You better put a domain in there. Because if you don't put a domain within your mathematical model when you're solving this equation out, you're going to run into stuff that just doesn't make sense. Okay, so here's our domain. We did our mathematical model, And in this model, I gave you a restriction here. Your bus has 60 seats. So we would have to write the math out. Our ultimate goal is to find out how much each student is going to pay. But remember, our model would involve a domain. My domain in this particular problem, once I wrote my mathematical model, I would put in there, I can use everything solving this out with my model, except for this. All whole numbers that are less than or equal to 60. That's my domain. I could use 0. You remember whole numbers start with the number 0. 0, 1, 2, 3, 4, 5, and so on and so on. I could use 0. What would that mean in this particular situation? Two things. It would first mean that 0 students went on there. They made 0 money. Nobody went. So they probably canceled the field trip. Or it meant that the school just paid for everything. So therefore, the money they had to pay was 0 because the school just paid for it. Okay, yeah, I get what you're saying. Whole numbers less than or equal to 60. Yeah, all that makes sense. But okay, what does that mean? Like, okay, you said doesn't make sense, blase, blase. You got to remember something. Why did I put that restriction in there? I have a domain of all whole numbers less than or equal to 60. Don't forget that bus holds 60 people. So if you perform a mathematical model to get the answer and it caused anything that would cause it to be greater than 60, that doesn't make sense because obviously no more than 60 students can sit on the bus. So therefore, I have to make that restriction. Also, I made the restriction of whole numbers because in this particular thing, we're talking about money. So money is not negative, not in this instance anyway, because a student is not going to be paying a negative amount. They will all be paying a positive amount. So therefore, my restriction in my domain is all whole numbers less than or equal to 0. Okay, let's try some math problems. You'll be given a function. Here, this function is x plus 5 over x minus 3. And remember, the rule was just set the denominator equal to 0. Perform a few mathematical computations. That's gone. So I'm left with x equals 3. So I write my domain. My domain is all real numbers except x cannot be equal to the number 3. So that is my domain. My answer, my domain, is this part. All real numbers except x is not equal to 3. Okay, look at the equation. Just look back and think about this. If I put 3 in there, it works on top. I get 8. But if I put 3 on the bottom, I'm going to get 0. What is 8 over 0? 8 over 0 is 0, which is it's undefined. It's undefined. It's impossible. You cannot have a 0 on the bottom. So that's why we have this domain. 3 would not work. But yes, I could put any other real number in that equation except for the number 3. Okay, next. Set my denominator equal to 0. Now would be a good place to pause the video. Do your computations. Look at my hint. Look at my hint. Hit pause, and when you think you have your domain, hit play. Minus 5 on both sides. That's gone. I divide by 4. And I have the x is negative 5 over 4. Is that what you got? So let's write our domain. Our domain is all real numbers except x cannot be equal to -5/4. Okay, here we have another one. Look at my hint before we get this one started. Yes, a domain could involve two exclusions. I'll underline them. You do have two exclusions here. This is a binomial n plus 10 over two binomials multiplied together, 3n plus 4, and then n minus 2. So I will get you started and show you how to get started. And then I think you should pause your video and then hit play when you think you have your total answer. So -4. That is gone because that is 0. Divide, divide. I get the n is -4/3. And then over here I add 2. And I get the n is equal to 2. So I'm ready to write my domain. All real numbers except x cannot be equal to -4/3 or 2. And if you have 2, just put them together with a comma. And most of the time, it is commonplace to put them in numerical order. Okay, this one is no different than the one we just did. It has two bottoms, two exclusions. You might not see them. I'll underline them for you. Pause your video. Try to do it. And then when you think you have it, hit play. Okay, my one over here on the left is already solved for me. Do a little math over here. And I get +7, so I'm ready. All real numbers except x cannot be equal to 0 or 7. Okay, here we have a binomial 3x plus 7 over a trinomial x squared minus 9x plus 8. Same thing. Set my denominator equal to 0. Okay, read my hint. Factor first. And yes, this one will have two exclusions. But to solve this out, you must factor. So pause the video when you think you have it. Hit play. Okay, so I factor out. I have to think about my two numbers. I know my two numbers here are 8 and 1. Where did that come from? Remember, they have to multiply to equal your C, which is 8. And they have to add to equal your B, which is -9. Only issue here is you have to be very careful about what signs you put in here. This is right. -8 plus -1 gives me -9, and -8 times -1 gives me 8. I now have two things. This is exactly what we just did. Set them both equal to 0. It's a minus. So +8, it's gone. Other side. So I'm ready for my domain. All real numbers except x cannot be equal to 1 or 8. All right, let's try to find a domain of a rational function of a real-world application. So, no reason to write the mathematical model. That's not our agenda here. We are trying to find out how much each person that's going to attend our event is going to pay to get in. The only restriction that I have given you in this problem, that the venue where you're holding your event will only be able to hold 250 people. So we're going to write the model. We're going to find out how much the cost is per person. But within that model, we do have a domain. Pause your video, write your domain. When you think you have it, hit play. My domain in this one would be all whole numbers because remember, this is money, so we would not have negative numbers here. And we do know that our venue holds 250 people, but it only holds 250 people. So all whole numbers less than or equal to 250. Hope you did all right with that one. So if you ever hold an event, make sure that you have a domain within your mathematical model, or your calculations will not work. So thank you for viewing Domain of Rational Numbers. Be sure to always hit subscribe because you will always hear about new and exciting ways to make math easy with Miss Terry Dabbit. You can also follow me on Twitter at Math with Dabbit, or if you need any live help or tutoring help, you can also contact me at tntcenter.com. Thanks for viewing.